Hi everyone, today we're going to talk about geometric sequences and series, like how to find the nth term and partial sums. Get ready to unlock the power of math together. Let's dive right in. So a geometric sequence has a common ratio between consecutive terms. Now, in order to find that ratio, or what we label as R, you are going to divide your term by the previous term. So let's say you have the third term divided by the second term. So that would be your common ratio, or your R. So when you are looking for a recursive formula, you are going to indicate whatever your a sub 1 is, which is your first term, and then you are going to take whatever that ratio is and multiply it by a sub n minus 1. Again, remember, this is talking about the fact that this is a previous term. That's what that indication is. Whenever you are trying to find the explicit formula for an nth term, starting when your n is 1, you have a sub 1 times your ratio and your n minus 1. Remember, this is just like that exponential formula that you learned before. Finding the sum of a finite geometric series is given as so. And when you are trying to find the sum of an infinite geometric series, when your absolute value of r is less than 1, can you use the formula like so? So let's look at some examples together, and then we'll use these formulas to help us to answer those questions. Now here you have a sequence that is given to you. Now what we're going to do first is we're going to find r. Now r, again, is taking one of your terms, so let's say negative 9 over 7, and dividing it by your previous term, which is 3, and my r is going to be negative 3 over 7. So that's my r value. Now, when I want to write a recursive formula, again, just like above, you're going to indicate what your a sub 1 is, which is your first term, which we know is 3. And then you're going to write your general formula, a sub n. Now, you know what your r is. We got negative 3 over 7. And then we're going to multiply that by a and then sub n minus 1. So there's your general recursive formula. When we are writing an explicit formula, again, we're doing a sub n using the formulas from the previous slide. What we're going to do is we're going to find our a sub 1, which is 3. And then in parentheses, you have your r value, which is negative 3 over 7. And then raising it to the n minus 1. So that's, again, just your general formula. When you want to find your 8th term, we're going to use the explicit formula as we just had here in letter C. So we're doing a sub 8. We're doing 3 times 3 sevenths, negative 3 sevenths, and then n minus 1, which is 8 minus 1, approximately negative 0.008 for our 8th term. Now we're going to find the sum of our first 8 terms, so you're actually going to use the sum of a finite geometric series. So we're going to do s sub 8, and we're going to do our formula here. So you have a sub 1, which we know is 3, parentheses 1 minus your r value, so that's negative 3 over 7. Raise it to the n power, so only that gets raised to the 8th. And then in the denominator is 1 minus, and then negative 3 over 7. Now, why did I put parentheses? Especially because you've got those negatives there. You do just want to be careful that you don't forget that it's actually subtracting a negative, and you don't just accidentally type in just a minus sign. So when we find our sum, it's approximately 2.098. Now we're going to find the infinite sum, so that's our last formula, so s sub infinity. Now we can do this because our r value, our absolute value of r is less than 1, right? So 3 over 7 is less than 1, so we're good there. So you have your formula here, so that is a sub 1, so that's 3, and then 1 minus, and then negative 3 over 7, which gets you 2.1. Okay, here in this question, you are finding the first term of this geometric sequence, and you're given two sort of data values or two terms, right? What we're going to do is we're going to just write what we know. So we have a sub 2, which we know is 6. And then we also know a sub 5, which is 162. So what we want to do is we're going to say, okay, well, whatever I get for my R value, right? Which we know is I take one term and divide it by the previous term, I'm going to get the ratio. But in this case, if I move forward, right, that would still be the same thing as multiplying that ratio, right? So what am I doing? I can write myself an equation. I have 6, and then I'm trying to multiply by r 3 times. So multiplying by r 3 times, that's r to the third power. And I want to get 162. So if I solve this, if I divide by 6, I have r cubed is equal to 27. And if I take the cube root of both sides, my r value is equal to 3. So I know that that's my ratio, right? But if I want to find a sub 1, if I go work backwards, I'm going to have to divide by my r, which I know now is 3. So 6 divided by 3 is 2. So my a sub 1 is 2. Here in question number 3, you have a little word problem here. What do we know? We do know that the value in the first year of ownership is 430,000. So that's sort of like my beginning amount. The value of the home does appreciate or goes up by 3%. Now we want to know what the value is in the 10th year of ownership. So we want to sort of think back to what we learned. So right now in Unit 8, what you learned is that explicit formula, right? So you learned a sub 1, and then you learned r, and then n minus 1. In Unit 7, which was our exponential and logs unit, you learned pretty much very similar formula here. And that was your exponential growth or your exponential decay. So I want you to remember that this is the same thing as that, right? There is that connection for your rate and then getting the ratio there. So what I want you to think about is this. What you have as your R value, right? Our R value, in this case, it's 1 plus whatever is appreciating, so 0.03. So my R is 1.03. Again, that's exponential growth, right? The home value is not only at 100% or 1, it's increasing more than that. So that's the 1.03. So now if I use that explicit formula to get a sub 10, because I'm looking at the 10th year, I'm going to put my a sub 1, so that's 430,000. My r value is 1.03, and then I have n minus 1, which is 10 minus 1. So what I'm going to get is $561,052.47. Thanks for learning with me today, unlocking the power of math one problem at a time. Don't forget to like and subscribe for future notifications on Precalc videos. See you in the next lesson.